Well, we got another unit in for repair. We get lots of fence starters sent to us for repair, but this particular one is a Gallagher M600. This model was around from 2005 to 2017 or so. So I had about 12-year production run on the thing. So right now, as of 2020, early 2024, parts still available for it. But you know, who knows what happens in the future? But right now, the parts are still available for it. So let's, for now, let's take it. I'm not going to plug it in. I'm just going to open it up because it's in here for a reason. And this particular one's a 2008 model, so it's got 16 years of age on it. And let's see. These have those stupid tamper-proof Torx in there, so I can find the right one. There it is. Flip this around. Now we need to snap off this little orange thing on the side. Hopefully it's this age-rated issue. Oh yeah, this had an old yellow transformer that they used there for a period of time. This has been worked on before. It's got a 2008 circuit board in it. But they used this yellow transformer for a period of time and they don't use it no more. They went to kind of a blue one later on and they went to a brown one. It was the last year they had it. But the yellow one's the original style. But look at that little lightning rod deal inside there. It's all burnt up. So power surge got a hold of it or what happened. But see, and save the board if we can. If not, we're going to have to replace it. But let's check this capacitor first. It's a 30 microfarad capacitor. So there's no polarity to it. We'll put our meter on capacitance. Test across it. Let's see. 29.7. So, and this is the original style. This is the gray one. They went to a blue one later on. So the gray one's that's the original. So this got, I think, original parts. There is some work they've done to it up here. It's like this trace that burnt up at some point in time. They soldered a wire across that burnt trace, which is fine. But let's plug it in. Just see what it does. We need to reapply it, reconnect this power cord wire that popped off. So I'm just going to smash that down. I probably need to replace that connector. It seems a little loose. Ooh, that's pretty boogered up down there too on that power cord. All right, let's see. Plug this in. Flip it over and see if we can watch what it does on the outside, because it has should have a row of lights that lights it from red to green, red, yellow, green from bottom to top. Well, still clicking, but I imagine with all that arcing going on, look, there's a burnt spot right there. So that's not good. So lightning or something caused that. Either the wire that was there was arcing for a long time, or lightning came on this is a fence side. Lightning came in on the fence, burnt that board up, or that section there where that little lightning rod was all burnt up, and that's a leftover scorch mark right there. I don't know. Let's turn it on. Let's see what we got going on here. Let's put our meter on it. I'm going to put no load, peak voltage. We'll read our voltage right there. And these are usually around 8 kV plus or minus. Turn it back on and try this again. It's all set up. .3, so I think our issue is that contact on the inside. It's not making it to the terminal. I'm talking about that one right there. So put that down there. Let's unplug the power cord from the board, and we're going to put new connections on that. Let's pop this board out of there. A little that. Oh, it looks like the contact in the board's okay, but we're going to have to run a wire. Have to see if we can clean that up some. I have to run a wire. Now, what we're going to do, we probably just need to get rid of this contact here. This is a basic 1/4 inch female spade connector. Is basically what it is. And so, the standard size. So if we clean this up, we can drill that out, pull that off there, put a standard female spade connector in that hole, clip a wire on, and then solder it to that spot right there, so that's in the same track as that. Let's get our Dremel tool out, Dremel type tool, rotary cleaner brusher thing, and we're gonna just see what. I just want to get all the big chunks of crap off there that we can. A lot of it, yeah, see, that's why it's not getting there. This trace right there's all burnt up. A little bit of solder left over there, so solder iron's powered up. So I think we've, hopefully, if everything goes as planned, we can heat the solder joints up, pull that solder off. That little female spade connector pull right out of there. Okay, let's heat that up. Yep, solder's coming off there just fine, so I think we'll be able to pull it off there. I think. Let's see. Alright, so let me get my drill. And we'll get a drill bit. Let's see. Let's try that one. Dead center it best I can. Might have to go a little bit bigger because we're just going to use one of the red female spade connectors. Yeah, we're going to go a little bit bigger. Let's just get one of these little stepper bits. That's big enough. Alright, and we don't need heavy gauge wire. Yeah, there's a lot of voltage coming out of these things, but the amperage is not super high, so like a 20 gauge wire is fine. Here's some black wire right here. This will work. So what we'll do is we'll strip this back. Crimp this on. And let me grab the front case again real quick. We probably will when we can try cleaning that, because this, I mean, it's not all that bad. If you can clean off some of that crap off there and save from having to replace that, we'll do that. But if we need to replace it, it's pretty easy to replace. Okay, let's cut this wire a little long. Go ahead and we'll plug this on here. And then we'll run that wire through there. And then this one, you can look through the case, a little window right there. Get them lined up. Okay, this one's still not big enough. It's going to have to get the initial spade through there, but we need to just go a little bit bigger. There we go. It should fit down there all the way. There we go. That. Alright, so we're just going to solder it right to there. So I'm just going to cut it to length. Put this a little long so I got a little room to play with. Strip that back. And then we're going to add a little more solder to that spot there, just so that way there's just a fresh coat on it. Alright, we'll tin that one, the wire, by adding some solder to it, and then we'll add some solder there. And we should be able to grab that wire, lay on top of each other, and hold them both together, heat them both up, let them flow onto each other. Should be good there. So let's put the capacitor back in. Let's get the power cord. Is it this one? And I'm going to go ahead and place the spade connectors on these, because these are just the brittle feeling. When I was putting them back on, the first one I put on there, it felt pretty crunchy. I was like, and when I squeezed them to tighten it up, it felt like it was about to break. It didn't feel very stout. Like the metal was pretty brittle. So now we're going to crimp on some new ones of those. These take a size smaller. Spade connector versus the 1/4 inch. Size it takes is a 1/2 millimeter, it says. Okay, whatever size that is. So crimp those on. Okay, so now we'll take wires and plug them back on where they need to go. Nice snug fit again. case back on there. Just persuasion. Come on, 1, 2, 3. There. All right, we'll get the meter turned on. We'll get this unit plugged in, and we'll hope that we get 8 kV plus or minus. So look at this number right there. 8.3, 8.7, 8.8. So over almost 9,000 volts out of this thing. Let's see what kind of load we get. Let's see what the pulse speed is. It's good to see how fast it pulses and all that fun stuff. Alright, pulse speed. How often does it click? It clicks every 1.3 seconds. How often is the shock on the fence itself? 0.13 milliseconds. So very, very quick snap on the line. Okay, let's flip it back over to kV and joules. Let's see what it is under 500 ohm load. Now this is a 6 stored joule unit. So output joules will probably, peak output joules probably be like 3 plus or minus. Maybe up to 4. So this is C. So we're at 500 ohms load. So we're at 500 there, 500 there. Now we're going to look, we're back on kV and joules, and look here for our joules. Of course, our kilovolts, and putting it under a load, it will drop. We're at 4.6, 4.7 joule output. Let's go to 200 ohm. Yeah, we're 4.3, so we've gone past its threshold. So it's probably between 4.5 and 5 joule output. So 4.7 joules output is what we got. We went to 200 ohm load, which is even a heavier load across fence and ground. That dragged it down even more. So 4.7, maybe 4.8 might be the max. If we had like a 300 or 400 ohm load between the 500 and the 200 number up here, we probably would have found the sweet spot for it. But it was peaking out joule-wise about 4.7. So pretty good for a 16-year-old fence charger. It's, like I said, it had a little bit of work done to it. The board had been worked on before, but transformer's original. They haven't used the yellow one since like 2009, and this is a 2008. So it's got the original transformer in it. The capacitor, I think, is original too, and the board is a 2008 as well. So it's a 16 years old and still original parts to it. So that tells you the Gallagher stuff pretty reliable. That's why you pay more for this stuff, but it's reliable. Well, that's it for this video. Hope you like the stuff. We do a lot of repairs on fence chargers. If you got a question, ask it down below, or give me a call. There's links down in the description below to take you to our website, but there's our information again right there. So nice cheap fix. We got a little labor in it. Ain't much. We only spent 15 minutes basically doing the repair on the dumb thing. So we'll put the screws back in it, snap the cover back on. I gotta clean that terminal thing still a little bit, which we'll use that Dremel, this tool here. We'll use it and buzz that crap off there a little bit more so you can get some of that crust that's built up on there off. But I think we'll be ready to go here before too long. But thanks for checking out our video, and hopefully you have a good rest of your day.